In the 100 years or so since we came into being, Western Electric has built more than 320 million telephones for American homes and business. Collaborating with our associates, the Bell Telephone Companies, Bell Laboratories, and AT&T Long Lines, we've played a major role in building one of the world's technological wonders, the National Automated Telephone Network. If there is one constant in our growth during that span of achievement, it is change, and our continuing response to it. Change in science, in technology, in what our customers need and want. Change is coming at us more rapidly now than ever before, and from more directions. The rule book for the way we operate is being rewritten.
What I'd like to discuss with you is a problem that I'm having with one of my customers, namely cost control. Do we have a feature package associated with that aspect?
Yes, we do. Do they have various facilities?
They do. They have different types of band watts, plus tie lines and foreign exchange.
What I'd like to do is show you some slides.
We're servicing and selling in new ways.
Better understanding of how the feature.
Through our Bell salespeople, we have act with our customers. There are 23 phone companies out there with different needs and problems. Our job is to make them familiar with the whole spectrum of Western's products and services, from wire and cable to the last word in microelectronics, and show them how we can save them money.
Think of Western Electric, and one of the first things that comes to mind is wire and cable. We've been at it for a century, and to this day, nowhere in the world will you find more of it being manufactured to the tune of over 400 billion conductor feet a year. That's nearly enough to run a line from here to the sun. A big change in recent years is our move to become system conscious. We take extra pains to be sure that from the telephone exchange to the customer's premise, the customer gets not only what he needs, but if it means something special, we can design a system to take care of it. Another significant change is a whole new technology. Back in the early 60s, when Bell Laboratories was developing the laser, researchers thought they might have a powerful new medium for sending voice and other signals via light waves. It took some years of searching for the perfect optical carrier. They found it in fibers made of glass. Under computer control, chemical vapors are deposited layer by layer on the inner wall of a quartz tube, each layer giving it unique optical properties. From the 4-foot rod we've processed, we can draw more than 6 miles of fiber. Fiber that transmits light, just as copper wire transmits electric current. In the future, we expect to manufacture glass fibers as routinely as copper wire. Ultra-transparent, hair-thin fiber, strong as steel. An exact replica in miniature of the rod from which it was drawn. Fibers that will carry pulses of light triggered by electronic signals that will transmit voices, music, computer data, bringing a new competency to communications. 12 fibers to a ribbon, up to 12 ribbons to a cable. A single fiber can carry 672 voice messages. A single cable can handle 48,000 conversations, or 72 TV channels, or millions of bits of data. In cities and towns where underground ducts are choked with old cable, Light Guide will prove to be a lifesaver. For while only a fraction of the size of a typical city cable, Light Guide can carry more than twice the load.
When scientists at Bell Labs invented the transistor and Western Electric people began to manufacture them, the new era of solid-state electronics was launched. Since that time, microelectronics has become so dynamic a force for change that it may well have as profound an effect on how we live as the Industrial Revolution.
We've seen it all happen here in the last couple of decades. Technology's racing forward at a clip without precedent, from printed circuit boards on which we wired transistors, diodes, resistors, and capacitors, to the same components now so small they're nearly invisible, sandwiched by the thousands in these integrated circuits.
The tiny bits of semiconductor circuitry we call chips are finding their way into all our products, some behaving in very strange ways.
I'm sorry. We are unable to complete your call as dialed. Please check the number and dial again, or ask your operator for assistance. This is a recording.
What you just heard is another new semiconductor technology that's become part of the Bell system. Magnetic bubble memories. They are magnetized areas in a thin film called bubbles because of their appearance under very high magnification. One of these bubble chips can store 68,000 bits of information. We're making a 4-chip device that provides a wide choice of voice messages, handling up to 500 calls at one time.
For calls outside your local calling area, it is necessary to dial the digit 1 before the number.
The most remarkable advance in microelectronics is the microprocessor, a computer on a chip. The microprocessor has the computing power of a room-sized computer of 20 years ago that cost over $100,000. While the cost of setting up for production of these complex chips is phenomenally expensive, we're now able to produce them in batches, which brings the cost per chip down to a very reasonable level.
We grind and polish the silicon wafers to a mirror finish, then process them through a series of chemical coatings and maskings. For some stages of the work, we have to operate in ultra-clean labs. A speck of dust can wipe out a microprocessor's reliability.
The masking and coating create the circuit elements, 100 chips to a wafer, about a 20th as thick as a sheet of paper. Each chip containing many thousands of transistors and other components in its layers of circuitry. Microprocessors are the key elements in more and more of our most sophisticated equipment packages because they have the power and flexibility to program the equipment to do just what we want and reprogram it when changes are needed. Since the slightest flaw degrades their performance, some chips don't make the grade. But the ones that do will be 1,000 times more reliable than the old technology.
An outstanding example of the microprocessor's potential is our Dimension Private Branch Exchange, or PBX, a telephone system for business that has received an outstanding response from our customers. Dimension is more reliable, versatile, and maintenance-free than any switchboard we've made in the past.
We spent over 2 years developing Dimension PBX into a kind of speech superhighway. It uses software programs like a computer to give the user complete control over his private telephone network. With its powerful memory, it can be programmed to do many different jobs, making each one a custom order fitted with the special capabilities the customer wants. It takes about 1 week to test and debug the system. We go through simulated field tests, looking for any discrepancy between what the customer ordered and what's been programmed on the PBX tape. Then we run it another week on its own self-diagnosing tape. Dimension has a built-in warning system.
Change, we've always had it. You keep improving, making small changes, when suddenly the technology takes a giant leap. When we went from electromechanical switching to electronics, it was like going from the piston engine to the jet. Dimension is a leap of that magnitude, yet is compatible with the existing telephone network. We're putting our PBX into a compact box, and we can pack even more improvements into it. Then one day, there'll be another quantum leap, maybe to the size of a shoebox. Who knows?
One specialized version of Dimension is designed for the lodging industry. It's a communications nerve center that enables a complex hotel system to keep track of the status of guests, personnel, and facilities, with a lot of automatic recording and billing features.
First name, please?
That's correct. I'll ring the room for you.
Thank you for calling Origins Atlanta.
The front desk has a running record of available rooms and updated information of guest status from reservation to checkout. It can even control the heating, cooling, and lighting of unoccupied rooms.
Need someone to help you.
Our supply contracts with the phone companies call on us to maintain stocks of material to meet their needs. To make sure those stocks are available when needed, we operate facilities all across the country. We have to satisfy orders that range from nuts and bolts to prefabricated exchanges, from reels of cable to a 30-cent length of wire. This location, for example, where we warehouse some 24,000 items, is the size of 15 football fields. What we don't make, we buy from thousands of large and small suppliers of every kind. We've got 7 centers like this, strategically placed around the country, backing up our service centers and smaller warehouses that serve the companies directly. This saves the phone companies a lot of money in inventory and capital costs.
This is an automatic color sorting system, a Western invention developed by our Engineering Research Center to speed up our repair operations. Old telephones seldom die, even when they start to fade. Instead, the phone companies send them back to us after years of service, and we give them a new lease on life. Every year, we recondition over 30 million instruments, more than twice the number we manufacture. We run a network of these renewal centers to help keep telephone costs down through conservation and recycling. Some of us have been here a long time because Western was recycling products long before conservation got to be an urgent national matter.
You're looking at some of the 3 million pounds of scrap that arrive here every day at one of Western's recycling centers. This is one of the largest, most sophisticated operations of its kind, not to mention the world's biggest copper mine created from scrap. We also recycle some 20 million pounds of plastic a year. This also helps conserve petroleum. We've developed a process that makes it possible to refine pure copper from scrap that contains only a small amount of the metal. This tank house produces copper plate with a purity of 99.9%. We melt down these cathode plates along with copper scrap to make copper rod. Then we draw the rod down to the size we want and send it off to our cable plants. Western's the country's biggest private consumer of copper, but we get more than 1/3 of our needs from this process. The fact is, it's cheaper to recycle copper than to mine it. And the new technology we use does it with less energy. In short, we're conserving energy and materials and saving money at the same time.
As we have for more than a century, we continue to build telephones at the rate of about 14 million annually.
For years, the Tribline phone has been the last word in instrument design. It's still going strong, but nowhere is change more certain than in customer taste. Today, for example, a lot of people are showing an interest in more individualized styles, from the antique to the elegant. Whatever the taste, we're making phones for just about every communications need, business or residence. Whatever the model, we're building the same reliability into every instrument. We've always been proud of the fact that no appliance in home or office gives as much freedom from trouble as the telephone that has our mark on it.
Lifeblood of the Bell system is the National Telephone Network, a system so vast it would take a good part of our population to operate it, if we were still using the old technology. When we introduced electronic switching, ESS, into the network, it opened the way to our automated communication system and all the innovations that followed. The network is constantly changing and expanding as traffic increases, and new techniques are developed to carry information over telephone lines. Manufacture of ESS is a major Western Electric mission. This is the equipment that registers the number of subscriber dials and does the complicated things to connect two parties or link whole communities within the network. Electronic switching does it all, swiftly and accurately. ESS works like a chain of computers, using programming software to tell the switching equipment what to do, and sets up the maintenance routines the system uses to monitor itself. As telephone exchanges grow, the programs can be expanded or easily modified to give subscribers new services without having to rewire their phones.
Along with the advanced switching installations, our transmission equipment is moving in new directions. Transmission systems convert voice, data, and television signals, then send them over wires, glass fibers, or through the air. The challenge is to overcome the problems of keeping the signals strong and free of noise over great distances.
One of the ways we're doing this is with a new system that changes voice signals into digital code, the language of computers. These signals are practically free of noise and distortion. We can put up to 96 conversations on a single line this way, which means big savings for the phone companies by reducing the need to lay new cable.
First thing we should do is see what kind of return code we've got.
Nancy, want to look at this and see if you can help us here a little bit?
Oh, sure.
Like its name, software is intangible. Yet without it, computers and switching systems are dumb machines.
Why don't we consult one of our reports?
Software programs make them intelligent and guide their operation. As ESS takes over more and more of the network, it creates a growing demand for new programs with special features like call forwarding that benefit home telephone users. These are being produced by our switching software center, along with information banks for telephone offices that help reduce the high cost of maintenance.
The trend is clear. Software is becoming our #1 growth product.
The people who make up the Systems Equipment Engineering Group are the architects and builders of the network.
Select any group of two, and sure enough, the data gets over.
When Western sells a major electronic system, it is delivering a mountain of equipment and technology, composed of thousands of interconnecting parts. No two systems are identical. Each is custom designed so that what's new will be compatible with what already exists and fits smoothly into the network. Computer graphic programs are important tools for doing this job, assuring that all equipment and specifications are blueprinted the right way. The plans are designed directly on the terminal screen. Walls, columns, equipment bays. So too the specs for cabling, power, and lighting. And when it's all done, a computer-generated blueprint will guide the flow of work right down through installation and become a permanent record for any changes in the future.
Now, if you can hit cable rack all the way across to feed verticals BB through BH.
As installers, we work as a team. A few months on this job, then we move on to the next one. It may be just a small project in a remote area, or a big installation to handle over 500,000 calls an hour. Whatever the job, it's our responsibility to make sure the equipment doesn't start hiccuping after we're done and gone. We've got a long history of quality to live up to.
How about that one there?
Back in 1965, Western installers put in the first commercial ESS telephone office. By the early 1980s, more than a fifth of the Bell system was being served by fast, dependable electronic switching. At the rate of one new ESS office joining every day, the communications network is steadily taking shape on a continental scale. In no other country has the conversion to electronic switching moved so swiftly.
The forces of change, new and old, are a challenge, but we welcome it. The lesson of a century's achievement has taught us that change and opportunity go hand in hand. In 1978, the growing need for sophisticated communications throughout the world led to the creation of Western Electric International. In a brief 2 years before being consolidated into AT&T's new international subsidiary, Western Electric International successfully completed a 6,000-mile microwave network for Saudi Arabia.
The tradition of Western quality and reliability, established over the years, has served us well. It will continue to do so in the dynamic times ahead, for it is firmly grounded in an unchanging ideal we share with all members of the Bell system: providing the finest communications service anywhere at the most reasonable cost.